Hello there, welcome to Engineering Drawing Made Easy. Today's video we are going to work on example of a tangency problem where you apply the various rules you've learned about tangency to redraw this figure or try and recreate this figure. Right, so whenever you're given an engineering drawing, the first thing is you have to really study whatever figure or problem that you've been given to you. Try and break it down to the basic components or to the smallest components as much as possible, right? This makes the whole drawing easier. It makes it straightforward, and then it also helps you to know what to do and which tools to use and which tools not to use, right? So this is a very basic, simple engineering drawing or tangency problem. Yes, and then I think this one uses two of the three basic tangency rules that we have, right? We have the tangency rule for when two circles touch externally. We have tangency rules for when two circles touch internally, and when a straight line is tangent to a circle, right? So if this figure, if you take your time and study it carefully, realize that it has three parts or three distinct lines, right? You have this straight line here that has a length of 64 millimeters, and then you have this circle here that has a radius of 20 millimeters. Now if you look carefully, there is another arc here, right? This is an arc, and from the knowledge we have from our basic schools and high schools, an arc is always part of a circle, right? This is just a section or a segment of a circle. So this is an arc, and if you look at the direction, it has its radius coming from the center point somewhere here. Now you don't know the exact position, right? But then there is a center point somewhere here and has a radius of 51 millimeters, and this circle goes in this direction, and you have this one to come in. It's too many lines. So you have this circle here, let's say following this direction, right? And you have this one also in this direction. So if you look at it well, there are two circles opposing each other in, let's say, direction, right? Or in terms of their center, yeah, they are touching externally. Yes, I'm trying to find an easier way to explain how touching externally goes like, right? But I think with more practice you get to see the difference between when two circles or arcs are touching internally and externally. So with this particular one, they are touching externally because you have this center, this circle having the center here, and then this one having its center here. So those are the two arcs we have in this problem. You just have to study the figure and see the relationship between both of them, right? So to draw a figure, you mostly start from the easiest component that you can draw, then you build from there. In this particular one, for me, the easiest could be this line here, or if you prefer, you can draw this circle and continue from there. So let's start with the straight line, right? So it says you have a straight line of 64 millimeters. So assuming this is a straight line, A B, right? 64 millimeters. So you draw your line AB 64 millimeters with your straight rule or any straight edge you have, and then you go on to the next easiest thing to draw. Now you have to try and decode the thing to get it properly drawn, right? This particular circle, all you know about it is that it has a radius of 51, right? But then we don't know where the center is. But for this one is different, right? This particular circle is different because we know that the circle touches the straight line at this point and is tangent to it, right? And the tangency rule between arcs and straight line is that the distance from the center to the point where the line touches the arc, right, is the same as the radius. So this line touches this circle at exactly this point, and we have the center line to write on that line, on this straight edge. So the distance between this center and then this point should be the same as the radius, 20 millimeters. So with that in mind, you come straight forward to draw your center line at the point B, right? Forgive me, I'm still getting used to this tool, so it's something. This is a messed up center line. Yes, but then you have your center line here, and then the distance between here and here, right? The distance between this to the center should be, this is supposed to be 64. Should be 24, right? Or what is it? It's 20. So the distance here should be 20 millimeters. That should be the distance between this line and the center line. So let me clean this for now. Right. Let me clean this for now. But then you come here with your compass and stand the center point here. Let me try changing the color. Right. So this is going to be the new center. This is going to be the center for the circle with radius of 20 millimeters, right? So you stand here. You can, if you draw it well, when you open from here to here, it should give you the same 20 millimeters, right? So then you draw an arc to touch it at the end. You can draw the arc completely, you can draw it halfway. Whichever approach you want, is you're the one doing your drawing, right? So whichever approach you want, you can go about it. And then you come to the next thing. So the meant to do this, you're halfway done, right? Because you've gotten the straight line and you've gotten the circle as well. So you're halfway done, or more than half, let's say. And then the next thing would be this arc, right? Now with this arc, all we know about it is that it has a radius of 51 millimeters, but we don't know exactly where the center lies at, right? So that is where the tangency rules come in. Now if you study it carefully, you can see that this particular arc, right, touches the 64 line at exactly this point. Okay, and just like how we did from here, the distance between where the circle touches the line and the center should be the same as the radius, right? I mean, basic figures, properties of figures, when you have a circle, any distance from the edge of the circle to the center should be the same as the radius. So this should be the same as 51, right? But that alone is not enough to get us the specific point of the circle. So we come in again with the tangency rule for external tangents between two circles, right? And it says that when you have two circles touching externally, right, both of their centers fall on a straight line, and also the distance between the two centers is the sum of both of them, right? Because they touch externally. So the rule is saying that the distance from here to here should be the sum of the radius from here and then the sum of radius from here. Let me just give a sketch, right? So this circle, so these two circles touch at exactly this point, right? From the rules of a circle, or as a plane figure, right? The distance from here to here should be the same r20. Okay, and then this circle from here to here, right, should also be r51. That is, the radius should be 51 millimeters, because like I said, if you have a circle, the distance from the center to any edge or any point on the circle is the same as the radius. So this proves the external tangency rule, that if they touch externally, then the distance between the two centers would be the sum of the two radii. Okay, so the distance from here to here is 51 millimeters. I'm struggling with this thing. Yes, 51 millimeters. And then the distance from here and here should be 51 plus 20, which gives us 71 millimeters, right? Now the reason why we are doing this is that we have to draw from known positions or known points, right? If you have done technical drawing in basic school or high school, right, you'll understand, or even construction in mathematics in high school, you'll understand. And whenever you are drawing or making constructions, the position always matters, right? Because the position is what brings all the other figures together at the specific point you want. So the whole of this is to try and get the position of this particular center here, right? So let's go back and yeah. So let's come back here and see how we'll put that in drawing here. Okay, so we've had this circle, we have this line. Now the next thing to do is get the other arc, right? So let me start by changing the color of the brush so that we can see the differences. So from this point here, right, to the center of the second arc, we don't know exactly where it is, but we know the distance between it and this line, right? And it should be 51 millimeters. So you bring your compass here, you open to a radius of 51 millimeters, and then you draw an arc, right? So any reasonable length, you just draw an arc, and this arc tells you that the center point for the center point for this particular arc falls on this line somewhere, right? Or this arc somewhere. So you draw an arc from there, and then you go on again. You come here with your compass, and from how we mentioned earlier, that the distance between this center and here would be 71 millimeters, right? So you put your compass here and open up to 71 millimeters, and you draw another arc. Okay, now you have the distance of 71 millimeters on this line, you have the distance of 51 millimeters on this line, and they all meet at a certain point. So this point that we've gotten, or this intersection that we've gotten here, now becomes the, what do we call it, the center line. No, not the center line, the center point. Yes, the center point for this color will not be visible. Let me go with it. Will be the center point for the second arc, right? So you come here now, because then we found out this to be the center point for the arc, and you open up to a radius of 51 millimeters, right? Now from 51 millimeters, I mean, it should touch here. So if you stand here and you open up to here, it should give you 51 millimeters. That's a way to know that you've done your work well, right? Because then, yes, it's the distance between that and this line is 51 millimeters. Yes. So you open it up to a radius of 51 millimeters, and you draw your arc. Okay, this should work. Yeah, so this should work. If you do it well, it will give you the figure very easy, and then very, very straightforward, right? So yes, probably you can come in with your eraser and clean this portion, and there you have it. You have the figure easily drawn. This is one of the most basic tangency problems that you can come across, right? Let's see. So here you have your radius of 21. Oh, why do I say 21? 20 millimeters, right? And then this, you have the line of 64. Yes, and this has a radius of 51, right? But then the distance from here to here, right, is 71 millimeters, and from here to here is 51 millimeters. So that gives you that arc, right? Yeah, let me try and do it this way. So yeah, our 71, and this is our 51, right? So this one way to go about this particular problem is easy. You just have to sit down, take your time to understand the work well, and then you work your way around it. There will be another tutorial session where I go into details, or not necessarily in details, right? But then I use the drawing board and then the pencils to draw it, so that if you have to follow, you can follow it there, right? This is to just explain so that you understand the concept or the process of drawing it. Probably you might get a different figure, a lot similar to this, but then it will still be using the same principle. So with engineering drawing, it's always best if you understand the principles or concepts that you are working with, right? So There's one way to go about the figure. I mean, another way is, because then with this one I started with the line, the straight line, right? So let's assume you prefer to start with the circle instead, right? On your drawing sheet, whichever space you want, right? You can start by drawing a circle of radius 20 millimeters, right? Yeah, this, you have your center line here. Right, and after you have your circle, we have our line, our straight line touching it at exactly this point on the street, on the, what do we call it, at the at where the center line meets, right? So you can just draw your straight line here, and then let's say 64. Yes, yes. So right, and right from this, you've done two parts of the drawing. The easiest parts. Let me put it that way. Yes. So from there, you can go on to finding the center points of the second arc, right? And like we did from the other end, you stand here with your compass. Starting with a compass, open a radius of 51 millimeters, right? You draw an arc, and then with a radius, you stand here, and with a radius of what, 71, because then it's 51 plus 20, you draw another arc. And these colors are even similar. Okay, so after that, you get, that gives you a center point, and if you open your compass from here to here, if you do a good job, you should be able to, you should be equal to 51 and be able to draw from here to touch the circle, right? Or you can also measure 51 from your rule, and then you draw your arc there. Then you clean this part. Yes. So whichever approach that you would want to take, whichever approach you want to take, you'll still get there, right? You just have to understand what you are doing and the idea behind it. So yes, you just have to understand the idea. You have the idea behind it. Yes, yes. I mean, in real drawing, this you necessarily do not have to show the radii or the distance and all that, right? Unless you are specifically asked to dimension. I mean, all these things you don't have to show them. I'm just showing it so that you understand how we got there, in case you still don't get it right. But that's it. It's an easy, a very easy tangency problem. Yes, and you work on this, try and understand, and then you can go on to other more challenging problems. We will work on more, and I'd also upload a video on using the drawing board and a pencil, give you a very refined drawing. Yes, so I hope this was very helpful, and yes, if you have any questions, you leave it in the comment section, and also share it with your colleagues so that you all kind of learn and practice together.